Imagine standing on Mars, surrounded by silence and thin air.
You raise your arm and throw a paper airplane.
Instead of gliding, it drops straight down.
Mars offers almost no air to fly through. Now imagine trying to fly a helicopter here. For decades, scientists thought this was impossible. Yet a small machine named Ingenuity proved otherwise. To understand how, we must rethink flight itself.
On Earth, helicopters rely on dense air.
Spinning blades push air downward to create lift.
Mars completely rewrites these rules.
Mars's atmosphere is just 1% as dense.
Flying there is like extreme high-altitude flight everywhere.
Normal helicopter blades would fail instantly.
Engineers had to start from scratch.
Ingenuity looks like a helicopter, but behaves very differently.
It weighs about 4 pounds on Earth.
Mars's weaker gravity helps, but not enough.
Weight reduction alone cannot solve lift.
The real breakthrough is rotor design. Ingenuity's blades are unusually large.
Large blades interact with more air. But size alone still isn't enough.
Rotors spin incredibly fast.
Around 2,400 rotations per minute.
Several times faster than Earth helicopters. In thin air, speed replaces density. Fast rotors move enough air to generate lift. Ingenuity hovers above Mars for the first time. But flight is only part of the challenge.
There is no pilot on board.
There is also no joystick on Earth.
Mars is too far for real-time control. Radio signals take up to 20 minutes.
By then, the flight is already finished.
Ingenuity flies fully autonomously. Engineers send plans, not commands.
Once airborne, Ingenuity is on its own.
A downward camera tracks surface features.
Images are compared to calculate movement.
This replaces GPS, which Mars lacks.
A laser altimeter measures altitude precisely.
Computers adjust constantly.
Hundreds of corrections every second. All inside extremely limited hardware.
Less powerful than a modern smartphone.
Mistakes cannot be fixed remotely.
Ingenuity must correct itself instantly,
Or it would crash. Mars adds another challenge: extreme cold.
Temperatures drop below minus 130 Fahrenheit.
Electronics cannot survive unprotected. Ingenuity uses solar power during the day. Batteries store energy for night survival.
Heaters keep electronics warm at night.
Energy must be carefully balanced.
flying uses power needed for warmth.
Too many flights risk freezing overnight.
Dust complicates everything.
Dust can coat solar panels.
Less sunlight means less survival energy.
Every flight is carefully planned.
Flights are short by necessity.
Five, 4, 3, 2, 1.
Ingenuity was designed for 5 flights only. Engineers expected it to fail quickly. Instead, it exceeded all expectations, completing dozens of successful flights.
Each flight gathered valuable data.
Proving controlled flight on another planet.
This achievement reshaped exploration strategy.
Helicopters can scout routes for rovers. They can reach cliffs and craters. Areas too dangerous for wheels. Aerial views reveal hidden terrain.
Future designs may be larger and smarter.
Some may carry scientific instruments.
Others may assist human explorers.
Ingenuity began as a simple experiment. It became a proof of possibility. Knowing physics can be adapted anywhere.
Not by breaking rules, but respecting them. Lightweight design was essential. Fast rotors replaced thick air.
Autonomous intelligence replaced human pilots.
Every system worked together.
Ingenuity flies with Mars, not against it. One small helicopter changed planetary exploration.
Quietly rewriting what we believe is possible.
Flying where flight was never expected. And opening the sky of another world.
Every successful flight refined future designs.
Engineers learned how Mars air truly behaves.
Thin air behaves differently near the ground. Dust particles affect magnetic lift in subtle ways. Even tiny turbulence matters on Mars.
Ingenuity taught engineers how to predict it.
Sensors constantly measured vibration and stability.
Every vibration told a story.
Rotor blades flex slightly during flight.
Flexibility prevents structural failure. Carbon fiber made this possible. Lightweight materials were absolutely critical.
Every gram mattered on Mars.
Too heavy, and lift would fail.
Too light, and stability suffers.
Balance was everything.
Even landing is risky on Mars.
One wrong tilt could end the mission.
Landing legs absorb impact carefully.
Engineers tested this endlessly on Earth.
Inside the chamber, we maintain a precise simulation of Mars' atmosphere and its reduced gravity, allowing for critical hardware testing.
Yet Mars always has surprises.
Some flights experienced unexpected oscillations.
Software updates improved stability.
Ingenuity could learn from experience. Each flight made the next safer.
Initiating fine-tuning sequence, increasing RPMs by 10.
Fluctuation is minimal. Readings look stable, Dr. Chen.
Good. Locking in the parameters now.
Small changes had huge effects.
This is engineering at its limits.
Mars offers no margin for error.
Ingenuity stayed within that envelope.
Perseverance Rover were walking alongside.
Helicopter and Rover formed a team.
A new kind of planetary exploration partnership.
Data flowed back to Earth slowly. Engineers analyzed every frame.
Success was never taken for granted.
Each flight approval was debated carefully.
Risk versus reward guided decisions. Ingenuity earned trust, one flight at a time.
Eventually, it flew farther than planned.
Higher than originally approved.
Faster than first imagined.
Mars' skies became reachable.
Sind Reservierflaglands Afrikanereuking. All from a machine smaller than a backpack.
This changed how missions are designed.
Aerial scouts are now expected.
Mars is no longer only a ground mission.
The sky became part of the map. Ingenuity's lessons extend beyond Mars. Thin atmospheres exist elsewhere.
Flight concepts adapt to each world.
Mars was the proving ground. It proved physics can travel anywhere.
When engineers listen to the environment
And design accordingly.
Ingenuity didn't conquer Mars.
it adapted to Mars.
That is why it succeeded.
one quiet machine rewrote expectations.
Not with power, but precision.
Not with strength, but understanding.
This is how Ingenuity flies on Mars.
By respecting physics completely.
Proving flight belongs beyond Earth.
The first aircraft of another world.
Small in size, historic in impact.
Mars will never look the same again.
Because now we can fly here.